Hello dear students, welcome to our YouTube channel Kemfi Papermate. I'm Chatari. So today I will be discussing answers for the Edexcel IAL Physics Unit 4 October paper MCQ section A. So let's get started. So first of all, in section A, first question, it's related to the atomic structure. And when you are writing atomic structure of a certain element, it's really important to know that we should write the mass number in the top, and then at the bottom we have to write the proton number. So mass number is basically the number of protons plus number of neutrons. Here number of protons is 76, number of neutrons now 190. The answer, the value of this is 266, and the proton number is 76, so you are write it at the bottom. So it's pretty straightforward. Answer is A. All right, let's move on to the second question. It's related to the momentum, section momentum, unit 4 section 1 for the mechanics. So under that lesson you should learn about the momentum and principle of conservation of momentum and the momentum in terms of Newton's laws of motion. So based on that, based on the Newton's laws of motion, we can derive one equation which is force equals rate of change of momentum. Force equals rate of change of momentum. So since we have not been given the value of mass and initial velocity, final velocity, we cannot use mv minus mu. So we can use force into time. See, we can just take time to this side, and that becomes equal to ft equals mv minus mu. The product of force and time gives the change in momentum. So we don't have to have mass and velocity of the object to calculate change in momentum. If you have been given the force exerted on that object and the time in which that force exerted, if those two are given, you can easily calculate the change in momentum. So 150 multiplied by 15 is the answer, 2250. Answer is C. Let's move on to the third question. Third question it's related to the particle accelerators, linear particle accelerator, LINAC. So when it comes to LINAC, the main component of LINAC is the drift tube. So these drift tubes are getting longer along the length of the LINAC. There's a reason behind this. So remember, when it comes to LINAC, the polarity of the drift tube changes, and the frequency at which this polarity changes, it's constant. So frequency remains constant throughout. So when you read the first two sentences, it's obviously wrong, because it says in one sentence it's given frequency decreases, other sentence frequency of the applied potential difference increases. So obviously wrong. So when you talk about LINAC or linear particle accelerator, always remember frequency at which the polarity of drift tube changes remain unchanged. And then the third, and we only have third and fourth option. You have to pick one from those two. So now it's quite easy task for us. So why these tubes are getting longer? The reason is linear particle accelerator, as the name implies, it accelerates particle. The velocity increases. One more thing you need to remember is velocity within the tube. Velocity of each particle inside the tube remains unchanged, but velocity of the particle when it reaches from one tube to another tube, in between the tube, it increases. So when it is at the first drift tube, See, at point A or at drift tube A, let's say the particle's velocity is v1, and at drift tube B, at the beginning of drift tube B, the particle's velocity is v2. So v1 and v2, when you compare them, v2 is bigger than v1 because there is a electric field. So due to the resultant force exerted on the particle, it accelerates. So since velocity is increasing, we can see that we have already learned this equation, distance over time. So the time remains unchanged, time taken for the tube to change its polarity remain unchanged. Therefore, in order to spend the constant amount of time in each tube, we have to make the length of the tube longer because velocity is greater. So it covers a larger distance for the same amount of time as it moves to the second or the next drift tube. So answer is D. So option C also wrong. It says like the particle gain mass as they accelerate, but that is not the reason for this. Okay, all right. Then next question. It's a unit. Pretty straightforward, but still some students are struggling with this type of question. Remember, for not knowing the exact term and the equation which you had to use and everything. So it's very important to remember the equation, certain set of equations, including their definitions. So this is the term magnetic flux, and there's another term magnetic flux linkage. So the main thing is to know how to differentiate these two terms. So this is magnetic flux linkage, and this is magnetic flux density. Magnetic flux density. Magnetic flux density unit is Tesla. And magnetic flux linkage unit is Weber. But since we have now here we have two options with Weber, but there is another unit connected to it. So obviously these two are wrong. So we have to find another alternative unit for this magnetic flux linkage or magnetic flux. So equation of magnetic flux linkage or magnetic flux is this BA. So B is Tesla, unit of B is Tesla, magnetic flux density. A is the area unit is meter square. So the answer is, these two are wrong. Answer is A. A is the correct option. Alright. Then we will move on to the next question, fifth question. Rutherford's alpha particle scattering experiment. In Rutherford's alpha particle scattering experiment, there were 3 observations, and based on those 3 observations, he gave 3 conclusions. The first observation was most alpha particles pass straight through with little deviation. That is the first observation. So this observation helped him to conclude that most of the atom is empty space. The second observation was some alpha particles deflected through a large angle around 10 to 90, some alpha particles. So based on that observation or evidence, he concluded that a large concentration of charge in one place. Charge is concentrated in one place. Third observation, a few particles, alpha particles, deflected back towards the source side of the foil. So with a larger deflection, 180 or in between 90 to 180. So that means most of the mass of the atom and a large concentration of charge is in a tiny central nucleus. So that is the reason. So those are the 3 main conclusions based on this alpha particle scattering experiment. So I think from those 3 conclusions I mentioned, you can easily figure out the answer. Answer is the nucleus contains protons and neutrons. The Rutherford couldn't detect the type of particles which are inside the nucleus. So he was unable to identify the protons and neutrons inside the nucleus, but he was able to explain or conclude that the nucleus contains most of the mass of the atom, and the nucleus is charged, and nucleus is very small compared with the atom. All three conclusions are valid, but not B. Then question number 6, particle track. So in this particle track, they were talking about a kaon decay. So this is the particle kaon. Since it is uncharged, there's no any particle track behind it. After the decay, we can see two particle paths, X and Y. But we have not been given the direction of magnetic field, or we have not been given the charge of any of these particles. So we cannot come to a conclusion about the direction of the magnetic field we don't have enough data. And then even option B and C also we cannot come to this type of conclusions without having enough details. So in order to derive the charge of the particle, we at least have to have the direction of the magnetic field. So option B, C are wrong. Obviously answer is D, because since they are having two opposite charges only, they are moving in two different directions, because they yeah, that's the answer. All right, next question. We'll move on to the next question. Again, it's related to particle tracks. But when it comes to these two particle tracks, one is, it's like a small curvature. It has a smaller radius of curvature. When it comes to this one, it has a big or larger radius of curvature. Try to complete the circle. Then you can figure out the size of the radius. See, in this one, R is bigger than this R. And when you are comparing the properties, especially with the radius of curvature, there's one equation which is really important for us. It's R equals mv over bq. And in the question, they had mentioned the uniform magnetic field and the same speed, which means two things are constant here. V and B are constant. So we have to consider R. R is depending on two factors. One is mass, the other one is charge. So we have to check what are the properties which gives a lower radius, which gives a larger radius of curvature. So we are asked to compare the properties of Y with the properties of X. So when it comes to Y, it has a lower radius of curvature. So we have to find out why there is a lower radius of curvature. The reason is low mass. It should have a lower mass, or it should be less massive than X. So mass of Y should be less than X. And Q is inversely proportional to R. So since they are inversely proportional, if the charge is greater, R will be lower. So charge of Y should be greater than X, and mass of Y should be less than X. So answer is B. It's pretty straightforward. What you need to do is use this formula. Based on that, with the help of that formula, you can easily find the correct answer. 8th question related to circular motion, angular velocity. Angular velocity is given by omega 2 pi over capital T. So they had given the revolutions and the time taken. So 12 revolutions within 6 seconds. So one revolution, it's 2 pi radians. And if there are 12 revolutions, so you need to multiply 2 pi by 12. And the time taken for that entire 12 revolutions is 6. If you divide it by that, you can easily find the time omega, or angular velocity. So answer is 2 pi into 12 divided by 6, which is B. Good. Then move on to the 9th question. Capacitors. In these capacitor questions, there are a set of equations you have to learn, you have to remember. And one equation is this. Charge equals Q equals Q naught e to the power minus T over RC. Or we can use the linear function ln Q naught minus T over RC. We need to find the time taken for the charge to half. So we have to make T the subject. I will make T the subject and bring everything to one side. Ln, first make sure that you rearrange the formula correctly, otherwise it will be difficult for you to score that 1 mark. Ln Q naught ln Q. So natural log or log subtraction means log division. So T equals RC. You can take ln Q naught divided by ln Q naught over 2, because the charge remaining is what? Q naught over 2, because we are asked to find the time taken for the capacitor to, the charge on the capacitor to become half of the original amount. So RC value they had already given, it's 5. So 5 into ln, now Q naught gets cancelled, and ln 2. When you simplify this, it's 5 ln 2. Answer is D. So please make sure that you practice more calculation questions, especially when it comes to capacitors. You should be familiar with rearranging formula, substitution, converting exponential function to linear function. All these are important. Alright, then the last question, 10th question, which is related to circular motion. In the circular motion, remember, centripetal force, it's provided by the resultant force acting on the object. So as an example, most common example in circular motion, an object which is attached to a string. So if you rotate it, at the bottom, the centripetal force is provided by the resultant of tension and the weight. Weight acts downward, tension acts upward. At the top, tension and weight both are acting downward. So the resultant is T plus mg. In this case, car is at the top of the bridge and reaction force, normal reaction force acts upward, and the weight of the vehicle acts downward. So some students, they are confusing, like they confuse this question with this practical context given. So in this one, at the maximum point, at the top point, both forces are acting downward. But here, it is the maximum point, but the two forces are acting in the opposite direction. And one more thing, always remember, in circular motion, centripetal force is exerted towards the center of the circle. Centripetal means center-seeking force. So center, it's towards the circle, center of the circle. So in order to have sufficient centripetal force, weight of the vehicle should be greater than the normal reaction force. So mg minus r gives the centripetal force. So since we are asked to find the force exerted on the car from the bridge, we have to find R. So R should be the subject. So that is given by mg minus mv squared over R. So answer is C.